So, good afternoon, everyone. So today, it's my pleasure to be here to present or to share something that relates to my research field for you. So today, I would like to talk about the usage of the fiber derived the agricultural wastes in Thailand as the alternative biodegradable packaging materials. In the previous section, you will see from Dr. Wani, she also showed you we have many agricultural wastes in Thailand. And before we start our talk, I would like to show my university in case that I believe that not much people will know Mae Pha Luang University. We locate in the most north of Thailand, near Myanmar and near Laos. We are near the border. So very beautiful university. Please, if you have a chance, you can visit this one. Okay. Oh, okay. So for this one, I would like to focus on the molded pulp because, as I told you, most of the agricultural waste, it contains lignocellulosic compounds. So we can use it in many ways, like a paper, and one of them that grow a lot in the market will be molded pulp packaging. So it increased a lot due to the risings in the middle class population, the growth in the demands from the food packaging, electronics, healthcare sector. So nowadays, many business want to use the eco-friendly packaging, and molded pulp tray will be one of the most increasing or interested one for the packaging in this area, and the preference of the convenience and sustainable packaging in the market. In addition, an increase in the demand for the protective and convenient packaging, we also need the molded pulp to make a tray, to make a cushion, to protect it also. So it's grow a lot every year for the market needs of this one. And when we're looking for this molded pulp tray, it can be the good choice because it's environmentally friendly packaging. And most of the EU, they also need the molded pulp for the food packaging. And in China and Thailand, due to the source of the many fiber, so we can produce a lot of the pulp molded food packaging also. So what is the main material that we use nowadays? It will be sugarcane bagasse pulp. And now in Thailand, we use a lot of them until we cannot produce it more. So nowadays they change to use bamboo fiber, reed pulp, and also use the recycled pulp nowadays. And only the fiber in Thailand is not enough now because we produce a lot. We have many companies produce the molded pulp tray. So sometimes we also import some fiber from the neighborhood countries. And even as I told you, Thailand is one of the country who produce a lot of sugarcane bagasse because we are the third country who can produce the sugar in the world. So this one, see, we have a lot, but it's not enough for our country. So we think about the other kinds of the agricultural waste. In Thailand, we have many kinds of tropical fruits like a banana, pineapple, sugar, but we will not focus on sugarcane bagasse. We should focus on the straw. And we have many other things. So in this case, we also have the problem for the waste management about all of them. And in Thailand, as you see in the news, we have the problem especially for the air pollution due to the incinerating the waste material in open field. Every March to April, we will have very high levels of the PM 2.5. That is a new problem and affect our health. So this is the problem. That's why nowadays many researchers try to find a way to use all of this waste and to stop the incinerating of this waste. So I would like to start first with the sugarcane straw. So as you see, around 27 million acres of sugarcane are grown in many countries, and also in Thailand. So after we get it, all of this will be the waste that we call sugarcane straw. We cut the tip of them and some leaf. We use only the stem to make the sugar. So this is all of the waste that can happen in our countries, and we produce it a lot in Thailand. And around 50% will be all of this waste from the sugarcane straw. This is the real place when we harvest the sugarcane. So you will see all of this will be sugarcane straw after they cut only the stem and send to the industry. And this one, they normally leave it to the decay on the field, but sometimes they want to grow the new crop, new batch of the sugarcane, so they burn them. So it will be a big area that full with the smoke around there and also the PM 2.5 dust. And this is the sugarcane production in Thailand that I would like to show you. We have many, like 90 to 100 million tons. So we produce the straw around 20 to 30 tons also. So that's why it will be the big problems in Thailand. And for this case, what is the chemical composition that we can find from the straw? We found that we can see many contents of the cellulose and also lignin, really high lignin. So if Dr. Wani want to extract or find the source of lignin, sugarcane straw will be one of that. But also in my career, in my work, I focus on just only cellulose. That's why I use sugarcane straw to make the molded poultry from the fiber, only cellulose. And the next one that will be the agricultural crop that I interest will be pineapple leaf. I think everywhere that can produce the tropical fruit, we also have the pineapple leaves. What is the good thing for the pineapple leaves? Pineapple leaf will show the biodegradable materials, and it also show the excellent mechanical properties, the high cellulose content, low microfibrill angle, and we can use them to make paper, to make any sheet, any tray, and also the molded poultry. And some country, like in Philippines, they also use the fiber to make a clothes. And this is the production by years of Thailand. They produce pineapple. We produce a lot and increase every year. And this is our location in Chiang Rai province. We have many kinds of the pineapple. So in Thailand, we have around 6 types of the pineapple, the cultivar. We have the Trat Si Thong, Pattavia, Phuket, Intarachit, Nang Le, and Phule. So the main that we focus on will be Pattavia, Nang Le, and Phule that we can produce a lot in Thailand, and especially in Chiang Rai. Why I can say that? Because we actually, all of this one we use sweet honey Pattavia to grow in Chiang Rai, but the change of the appearance and characteristic show that we have to talk and set up the new name for them. We have to call them in the new name because it's totally changed for the characteristics. So we call them as the Nang Le, very juicy, smooth and sweet. And the next one, we grow Phuket in Chiang Rai, but it changed to very small size pineapple. And now we also export to Korea. If you can see from YouTube or TikTok, you will see it will be small one that you can eat the whole fruit after we peel off it. So this one is Phule. So we grow them just only in Chiang Rai to get this characteristic. That's why we call them geographical indication. And we can produce a lot and send to China because it's so popular in China. So after we harvest all of this Phule pineapple, the small size of them, see? Very small one. So this one, after we harvest it, we have to trim, to cut the leaves. And all of the leaf, you will see we have a lot of spike. So that's why we cannot use this kinds of pineapple leaf for the feeding, animal feeding. So we just leave it in the field, and when it dry, we burn them again. So this one is one of the pollution that happen nowadays in Thailand. So I try to use this one to also make it. And this is a big amount that we get the leaf in per hectare and per year. So you will see, this is 3 cultivars of the pineapple that I told you we can grow a lot in Chiang Rai province. That means we have a big source of the pineapple leaf all the year. And the next one also the banana. Banana is one of the important commercial crop in everywhere, I think, and also in Thailand. It contains a lot of the cellulose, so that's why I focus about this. The medium contents for the lignins also, so this is the good choice. In Thailand, especially in Chiang Rai province, because we are near the border, so we grow a lot of Cavendish banana, the green banana, and send to China again, a lot. So that's why what happened, we can produce the peduncle, that hold the hands of bananas. We produce a lot, around 2 tons a day per rai. This is the area, the unit of area in Thailand. So this is the way that they throw away the waste from banana in the fields also. So we focus on this one to make it, to use to make the model pouch tray also. So in this talk today, I would like to study the potential of the agricultural wastes, such as the sugarcane straw, pineapple leaves, and also banana peduncle, to make the model pouch tray and determine the properties of the tray from all of them. And one of the main idea that we want to do, we want to reduce and valorize the agricultural waste. So first of all, we just prepare the material, right? We got all of them from the farmers, and then we take it, we cut it and dry them for use as a pulping. And we also check the chemical composition to make sure that they contain the high cellulose enough to be the good source of the model pouch tray. And this is the yield. After we studied the chemical composition, we found that all of them show very high hollow cellulose. But just only sugarcane straw, is high lignin, and also banana peduncle. For pineapple, it's good choice because it's very low lignin. But after we try with the model pouch tray, high lignin can also help to improve or to increase the strength of the tray also. And this is just the example of the fiber that I show you. Actually, I would like to show you all of the fiber, but most of them will be almost the same thing. It shows very smooth and long, long fiber, especially for the pineapple leaves. Very long fiber and very tough. And also for the peduncle. But in case of the sugarcane straw, it's shorter. The fiber is shorter than this. So you will see from the mechanical properties of them is have a little bit difference. So this is the way that we can do the model pouch tray in small scale of my lab. So we just preform them for the pouch, we blend them with water, and then we put it into the mold and use hydraulic hot pressing to place it to make a tray like this. And we also check the mechanical properties, water wetting time, and thickness swelling, to make sure that it can be applied for the real use or for the next development. And this is the properties determination that we normally do, like the normal paper or the other tray. So this is a picture of the tray. You may confusing why for this one, SSF means sugarcane straw fiber. Why we have 2 of these? Because in this work, I focus on the way that we use for pulping. I use 2 ways for chemical pulping by sodium hydroxide. And the next one, we use steam explosion. Because we know that if we use steam explosion, they need just only pressure and temperature, no need any chemicals to use with this. But without chemical, you will see it will show the dark color because we use very high temperature and pressure, and we didn't remove anything from the fiber. So this is the way that we do for the sugarcane straw model pouch tray. We already published in the polymers. And the next one will be banana peduncle. So it looks lighter than when we compare to this one, but all of the shape or of the size, because we use the same mold to control them. So it will show the same thing. So from all of this, we will use around 15 grams of the dry fiber to make one tray. And this is a pineapple leaf fiber. So as I told you, we have many kinds of the pineapple leaves. So I do it separate from the cultivar for Patawir, Nang Le, and also Pule. And I want to prove that if we mix all of them together, what happened with this? So we get this one from the mix, but after we check it, it's not much for the difference of the property. So that means if you correct all of the pineapple from everywhere in the world or in my country, we can do it in the same process. And this one, I also developed from the normal Pule pineapple, so we add the chitosan to improve the strength of them and also mix with zinc oxide nanoparticles. So this one I already published also. And this is the mechanical properties of all of them. So, this one is not quite good when we compare to other. With the real texture, the pineapple leaf fiber will show very tough for the tray. And banana peduncle show very hard texture. But this is the after we test with tensile strength, elongation is a little bit, not much for the difference. And I show as the range because I do in many conditions. So this is the estimated range of them. And for compression also, see, for banana peduncle is very hard. It's not easy to break. So that's why we want to know which one is the best for any area, and it will be the data that we can use for the next application. And also this one, I want to prove about the way if we want to test them or we want to use them with the high moist product. Now I will not focus on the food because we have to check the food contact material safety, right? So this one, I just want to check the normal application in case that we place it in the high humidity or something that contain the high vapors of the water. So this one will be the thickness varying after we drop the water in the same volume and check the thickness. The changing of the size of them, you will see banana peduncle really love to absorb a lot of water and change the volumes of them. And also relate to this one, it absorbs water very fast. This is the time that we use to absorb the water in the same volume. Just only 30 seconds, but other is take around 1 or 5 minutes. That's why it's longer. So that means, so this one is very hard, it's very strong, but really love to absorb a lot of water also. But pineapple leaf fiber, it still have the good for the water, and sugarcane also. And as I told you, for sugarcane store, it contains a lot of lignin, so it can also show the good contact angle. So water will not show the wettability or spread on the surface of the sugarcane straw fiber tray. Okay, this is the conclusions of all of this. And when we see from this one, I also apply all of them to other application like a pineapple pad. We use it to make the sponge, cellulose sponge, because it's very soft and the length of the fiber is good to make the sponge. And for sugarcane store, we try to make it as a nanocellulose because it's not quite long for the fiber, but it still have the good points of them. So all of this will be the total area of my work now. And I would like to thanks for the final things for my university, Wirongrong University, and this is my research center for the innovative food packaging and biomaterials. And we also get some scholarship that relate to this study from PMUC, the funding grants in Thailand. And I would like to thank our partner institution who help us a lot for many equipment. Okay, thank you for your attention. This is a pictures of my university also.
That's beautiful. Any question about this presentation? Okay, we have a little bit behind of the schedule, so I think you can have another question in the person in the corridor next time.
Okay. Thank you very much.